Okay, we're going to apply the chain rule here. This, again, is going to become a composite function. Okay. What we're going to do here is we're deriving both of these. Think of this, our y, being of one function itself, and then u has a whole other equation to it. If you remember our chain rule, we had if h at x is equal to f.
And Alyssa Cherry, please come down to the main office. Alyssa Cherry.
So f prime at the original g at x multiplied by g prime x. Okay, so we find the derivative of the outside function multiplied by the derivative of the inside function. Okay. Well, here's a little easier to see. We know our f, or our outside function, is going to be our y, right? This will be our f function, and the u's are going to be our original g at x. Okay. Now, like I said, there's two ways to do this. We could do it the book way, which will be the easier way to follow, and then I'll show you it with one function inside the other. So the way your textbook has solved this is they've written it out like this. They've actually kept this in terms of our y, and they derived our first function. Since this is our first function, our y, they've left it at the derivative of this being 3u minus 2. That is this part of the function right here. Okay, that's our outside function, our f prime, and they've derived it. Okay, u is technically still inside the function. U represents our g at x, and then they multiply it by the derivative of our u. Well, our u, I'm going to do this on the side, technically is 2 to the power of a half. Okay, so when we put this out, or when we derive this, 1/2 times 2 will leave us with 1, and we're going to have negative a half, so we know this is essentially equal to root of x, 1 over the root of x. So they've written it out like this, 1 over root x. Okay, and then that is technically our h prime x. We've now derived our function here. So we derived the first part and the second part, but if you notice, I technically have a u and an x in the equation. Two different variables. Okay? We can write it this way. We then have to equate u in terms of x. Specifically in this question, if x is 4, we can solve for u. We know that u is equal to 2 times, and because we're solving when x is 4, 2 times root 4, well, u will be 4 in this case, and x will be 4. Okay, they end up actually being the same thing. So when we plug this in, I would replace my u with 4, and I replace my x with 4, and this would help me find. Do they want just a equation? No, they just want what the value would be. So the value of our h prime x. Now that's solving it with two different variables. You have to keep in mind and remember that you are using two different variables. Don't put in an x for a u or a u in for x. Another way we could have solved this, okay, is if I rewrote the question above. Our h at x, if you guys recall, was u cubed minus 2u plus 1, and u was equal to 2 root x. Well, if I decide to plug in my values, we did that in green, right? Yeah, u and u. We're going to replace them with 2 root x. Okay, in which case we'll now have h at x is equal to 2 root x cubed minus 2 times 2 root x plus 1. Okay? Now in this case, I'm going to try to highlight the parts that are going to be referenced to our y, sorry, f at x. So the f at x parts of this, if you guys recall from before, are our cubed here, our negative 2, and our plus 1. That's the f at x part of our equation. The g at x part of this equation are the values we've plugged in. Okay? The values we've plugged in are 2 root x and 2 root x. Okay? So technically this becomes a value. We're going to equate what the value of this is actually going to end up being here. What do we get at the end here? 2? Yeah. Okay. So when we go to equate what this is going to be, we can leave this still as 2 root x 3. This technically is negative 4 root x plus 1. Okay. I've now plugged in our equation here. And we know that this can also be written as x to the half, 2 root x cubed plus 1. Now, we haven't even started. You're noticing it's starting to get a little more complex when we go through this. You can rewrite the question the entire way out, and then you could try to solve it this way if you want, because now we only have x's involved in this equation, okay? And I can technically make this now 2 to the x 1 over 2 cubed negative 4 half plus 1. Okay. We can apply this cubed inside, which will then give us 2 cubed is 8. 8 x 3 over 2 minus 4 x half plus 1. Okay. I'm still working with h at x. I've just plugged in my value of x, or 2 root x. And then we can go about solving it this way. Okay? We can find the prime of this, and we'll eventually get the same answer. The only difference is we didn't really simplify this one. We left it the way it is, and this is an easy way to go about doing it. If we were to derive this, we end up with 24 over 2, which is 12x half. This becomes negative 2x negative a half, and that becomes 0. So we're left with 12 over root x minus 2 over, sorry, the other one's not a fraction. That wasn't a negative. It's just 12 root x. 12 root x minus 2 over root x. Okay? This would be essentially a simplified version. Let's zoom out just a little here. This would be a simplified version of what we have up here. The only difference is we only have the value of x, and in this one we have a value of u and x. If you are able to keep the function as different variables, it's actually a lot easier to go about finding the derivative of this. Okay? And this is the way the book has done it here for you guys. They left it as 2 different ones, and we just solve one in terms of the other. When x is 4, well, we just solve for u when x is 4, and we're able to plug in a value of u and a value of x. Okay? There's many ways you can go about solving these. The first way the book is solved is probably the simplest version.